Alright guys, so in this video I'm going to go over chapter 5 section 3 binomial probability distribution. A binomial experiment is a probability experiment that satisfies the following four requirements. Now from the name itself, binomial, so we're having two cases here. First things first is there must be a fixed number of trials, meaning there is a known constant number of trials that we're going to attempt. So for example, flipping a coin 5 times, I know that I'm going to be flipping the coin exactly 5 times. Each trial can only have two outcomes or reduce to two outcomes. And these two outcomes, we are going to call them success and failure. So in a sense, flipping a coin only has two outcomes, heads or tails. And for example, I care for heads, so I'm asking what's the probability of getting exactly 3 heads. So the success here is heads because that's what I care for, and the failure would be the tails. It doesn't mean success as in the word success itself, winning, or failure as in losing. No, it's more so I care for heads, so success would be heads. I don't care for tails, so failure would be tails, depending on the question. So if I asked what's the probability of getting at least 5 tails, right, out of let's say 10 tosses, then my success now is tails. The outcome of each trial must be independent of one another. So again, heads, if I get a heads once, if I get a heads twice, if I get a heads 3 times, it's not going to change the probability of my tails. It doesn't affect my next toss. So they have to be independent. They cannot be dependent cases. And lastly, the probability of success must remain consistent from trial to trial. So, for example, when we did examples of replacing and without replacing, the probability changed from trial to trial. In this case, from trial to trial, the probability must remain the same. So meaning there should be replacement. There should never be a without replacement kind of problem, because then the probabilities will change from outcome to outcome, or from trial to trial. Sorry. So let's look at these. We have decide whether each experiment is a binomial experiment. If not, state the reason why. So of course I'm gonna go over these, but you try to answer them yourself by maybe pausing the video. However, selecting 20 university students and recording their class rank. So we have 20 students, we're selecting 20 random students and recording their class rank. Well, we have four things that we have to care about. The probability not changing, dependent to independent, 2 outcomes. We have to care about all of that. So for this one, the answer would be no, it is not a binomial experiment. Why? Because there are 5 possible outcomes: freshman, sophomore, junior, senior, or a graduate student. So there are more than one outcome. There are not just 2 outcomes. However, selecting 20 students from a university and recording their gender, yes, because it fills and it takes all 4 requirements are met. Drawing 5 cards from a deck without replacing and recording whether they are red or black cards, well, that is no. Why? Because we never replaced. So again, without replacement. So the events are not independent. The probabilities change from card to card, from trial to trial, so therefore it is not. Selecting 5 students from a large school and asking them if they are on the dean's list, well, that is yes. Why? Because they're either on the dean list or not on the dean list. So there's only 2 outcomes here. Recording the number of children in 50 randomly selected families. This one is not, because there can be more than 2 categories for the answer. So number of children, they could either have 1 child, 0 children, 2 children, 4, 5, 6, 7, 8. Doesn't matter. So the idea is there only has to be 2 possible outcomes per trial. Alright, so binomial probability formula. Here is the formula for the probability distribution. So probability of x equals n factorial divided by n minus x factorial times x factorial. And if you recall, just that snippet before I go to the p to the x times q to the n minus x, that is just the combination formula. So it's combination formula times p to the x, so probability to the power x, times q to the power n minus x. However, the first part is just the combination formula. So what does n mean? N means number of trials, as always. N is always usually the number, the sample space, or the number of trials. X, oh wait, sorry, P is the numerical probability of success. So when I say what is the probability of getting a heads, well, the probability of getting heads is 0.5, so my P would be 0.5. My Q is the complement of my P. So if I said P was, say, 20%, then Q would be 80%, so the complement. And how do you find the complement? It is always 1 minus P. And if you want to find, if you know Q and you want to find P, then it would be 1 minus Q would be P. They are complements of one another. So Q is simply the complement of P. X is the number of success. So X is going to be the number that we care about. Okay, so when I say exactly 5 heads, then X is 5. So the probability of exactly S successes in N trials, pretty much if I said something like, what is the probability of getting, say, like I just said, 5 heads in 10 tosses? 10 tosses is the number of trials, so N is 10. My X is 5 because that's what I care for. My P would be 0.5 because it's heads, right? It's a coin, there's 50-50. And my Q would be 0.5 because 1 minus 0.5 is simply 0.5. Alright, so let's look at an example. According to the Bureau of Labor Statistics, 23% of the US workforce in 2015 was employed in the wholesale and retail trade industry. If 8 US workers are randomly selected, what is the probability that exactly 3 are employed in the wholesale and retail trade industry? So first things first is we have to check and make sure this is a binomial experiment and that all four requirements are satisfied. So the first things first is there must be a fixed number of trials. Again, they said 8 workers will be randomly selected, so we know there are exactly 8 trials. So 8 people are going to be selected, so we know exactly what the number of trials are, and it's a constant number. Each trial can only have 2 outcomes, or outcomes that can be reduced to 2 outcomes. These outcomes can be considered as either success or failure. So we're looking at these workers, and however, there are only 2 possible outcomes. Either the selected worker is employed or not employed, right? And the question was asking what is the probability of exactly 3 being employed. So the success here is the selected worker is employed, is not employed, right? That's what we care for. Is he employed or not? Or is she employed or not? But we care about, is she employed or is he employed? That's what we care about. So that is the success in this case. Next, the outcomes of each trial must be independent. They are clearly independent. Just because somebody is employed does not change the fact that the other person is not employed or whatnot, right? They do not influence one another. And the last, the probability of success must remain consistent from trial to trial. And the probability is consistent because the Bureau of Labor Statistics says there's a 23% of the US workforce was employed, so there's a 23% probability, so from worker to worker that won't change, right? So there's a 23% of success, so meaning my P is 0.23, so therefore my Q would be 1 minus 0.23, which is 0.77. So now I have my P, my Q, and now that we figured and the criteria are satisfied, we know it's a binomial distribution, so we can use the binomial probability formula. So I know my X, which is 3, because that's what I care about. Remember, the question says, what is the probability that exactly 3 are employed in the wholesale and retail trade industry? So I care for the success to be the employed. So 3 is my X. My N is 8, because that is the randomly selected workers. My P is 0.23, my Q is 0.77. So I can simply plug into the formula and solve. I can solve this by hand, or I can solve this using my graphing calculator, and here's a snippet of how that's done.
Alright guys, so I wanted an online version of this, but for the life of me I could not find it, so I'm gonna go old school and just record myself using the calculator. So for this example, the way you would do it using the calculator, of course you could always plug it into the calculator, old-fashioned style, where you do 8 factorial divided by and then 8 minus 3 factorial, do some by hand, whatnot. and then maybe some parentheses and 0.23 to the power 3. However, the way you could do it one shot is you go to distribution. See where in blue, so you would have to click second, distribution, and then you would scroll down to binomial PDF, not CDF, PDF. So binomial distribution, binomial PDF. Click enter. Now for some calculators, it will literally give you the options and you just fill them in. What's X, what's N, what's the probability, enter, okay. But for those who have this version of the calculator and it gives you this, you would go, first things first is you put the sample size, which is 8, and then you separate it with a comma. Then you put the probability of success, 0.23 for the example that we're doing. And then don't forget to separate it by a comma again. And then you put what it's asking for. So exactly 3, so 3. And then close your parentheses and then enter, and that should give you the answer.
Alright, so here is another example. Given there is a 0.85 probability that any randomly selected adult knows of Twitter, find the probability of getting exactly 3 adults who know of Twitter when 5 adults are randomly selected. So round your final answer to the nearest thousands. So, does this procedure result in a binomial distribution? Yes, it does. Why? We know the number of trials and it's fixed. There are 5. Are they independent? Of course they're independent. Somebody knowing about Twitter does not influence another person not knowing about Twitter. Number 3, is the probability consistent? Yes, it is. Given there is a 0.85 probability that any randomly selected adult knows of Twitter, meaning there is a consistent probability. And number 4, there are only 2 outcomes, either knows or doesn't know. So this is a probability distribution problem, a binomial probability distribution problem. Alright, so now my X, right, is exactly 3 adults. That's what I care about. How many adults are chosen? 5. The probability of success, 0.85. My Q, 1 minus 0.85. And then I could plug it into my calculator or do it by hand, and I should get 0.138. And I will be showing how to do this on your calculator after I do the next 3 examples. So here, what is the probability of getting exactly 4 who know of Twitter when 5 are randomly selected? Same case, the only difference is X is now 4. So if I plug it into my calculator and do my work, I should get 0.392. Now again, try doing this yourself, and then after this slide I will be showing you guys how it's done on the calculator. Exactly 5 out of 5, again, that would be 0.44. And lastly, at least 3 out of 5. Now, this one is saying at least 3 out of 5. So we know what's the probability of exactly 3, exactly 4, exactly 5, but at least 3 out of 5, that can be 3, that can be 4, and that can be 5. So I would have to add their probabilities. This is going back to chapter 4, when we have like an OR problem, right? Because the probability of 4, the probability of 3, or the probability of 4, or the probability of 5. So I can have all 3 of them, right? So the probability would be to add all 3 of those numbers that we got, and the answer would be 0.973. So again, here is how it's done on the calculator.
Alright, so for this one, I already showed the answers. However, let me show you guys how to do it using the calculator. So for the first one is exactly 3, second one is exactly 4, and then exactly 5, and then at least 3 out of 5. So again, you go to second, distribution, scroll down, binomial, PDF, and then its sample size, 5, comma, the probability of success, comma, exactly 3, equals, you get your first one, and then just rinse and repeat, just keep repeating it. So you have 5, comma, 0.85, comma, 4, and then the last one, 5, comma, 0.85, comma, 5. And then what you could do for the last one where it says at least 3 out of 5, we know that we're supposed to add, right? So we can do second answer, so that gives me this guy. Plus, let's add the top, 0.13. Now I'm gonna put every decimal that I see, just because when you do this in the homework, I don't know exactly how many decimals deep they would ask for. So you don't want to have a round off error or anything. So just put all of them just for the sake of doing it. And then your final answer should be 0.973.
Alright, so here are 3 examples. If you like, pause the video, try doing them yourself. I will be showing the answers in a second. Alright, so here's the answer for number 1. Here's the answer for number 2. And here's the answer for number 3. Now for number 3, I don't know how you must have attempted it, but for number 3, here is a snippet of what you could have done, right? Find the probability of at least 2 girls in 8 births. Round your final answer to the nearest thousands. So at least 2, that's 2. Probability of 2, probability of 3, 4, 5, 6, 7, 8, and you get 0.96484. That would be your final answer. And then if you round it to the nearest thousand, then 0.965. However, if you thought back to chapter 4 and thought about some complements, what you could have done for number 3 was find the probability of at least 2 girls in 8 births. So that is the probability of at least 2 girls. Or what's the complement? 1 minus the probability of 0 or 1, right? That is much easier than to do 6 times on your calculator binomial distribution. You could have simply done 1 minus the complement, which the probability of 0, if you did it, would be 0.00391 plus 0.03125. Add those two, subtract them from 1, and you should get 0.96484. And again, nearest thousand, so 0.965 would be the final answer. So hopefully this is the method you guys went for and didn't work hard enough. I didn't work that hard on this problem. Alright, so binomial distribution formulas. So again, n means the number of fixed trials, p means the probability of success in one trial, q probability of failure in one trial. So here are some new formulas. So the mean, the average of binomial distributions. The average is n times p. So the number of trials times the probability. The variance, sigma squared, is n times p times q. So the number of trials times the probability of success of one trial times the probability of failure of one trial. And then the standard deviation would be the square root of the variance. So once you find the variance, take the square root, and that is your standard deviation. And for the values of unusual and usual, again, same exact formula from before. We've already seen this twice before. It's going to be mu plus 2 times the standard deviation. And then the minimum usual value would be mu minus 2 times the standard deviation. So let's do an example. A coin is tossed 4 times. Find the mean, variance, and standard deviation of the number of heads that will be obtained. So first things first, tossed 4 times. So that is going to be my n. There's a 0.5 probability of getting heads. There's a 0.5 probability of getting a tails. Right? So the success would be 0.5 and the failure would be 0.5. So my mean is simply n times p. So that's 4 number of trials times my probability, which is 1/2. So 4 times 1/2 is 2. And then my variance is going to be 4 times 1/2 times 1/2, which is 1. And then the square root of 1 is simply 1. So my standard deviation is 1. Here's another example. An 8-sided die is rolled 560 times. Find the mean, variance, and standard deviation of the numbers of 7s that will be rolled. So this is an 8-sided die. So my success is 7s. From one trial, if I roll an 8-sided die, I have a 1 out of 8 chance of getting a 7. Right? It's an 8-sided die, so I have a 1 out of 8 chance of getting a 7. What is the probability of not getting a 7? That would be 1 minus 1 over 8, which is 7 over 8. So my p is 1 over 8, my q will be 7 over 8, and my n would be the 560 times. So my mean is going to be 560 times the 1 over 8, which is 70, and then you could do 70 times 7 over 8, which is going to be 61.25. That 61 over 4, that's simply a mixed number over there. And then my sigma would be the square root of 61.25, which is 7.826. Alright, so lastly, let's do a problem where we're going to be finding the maximum and minimum values of usual and unusual numbers. So McDonald's has a 95% recognition rate. Find the mean and standard deviation of how many people recognize McDonald's if a group of 12 are randomly selected. So again, the probability is 0.95, the number of people or the number of trials is 12, so 12 times 0.95 is 11.4, and then my standard deviation is going to be my square root of my variance, and I would get 0.7549. Just use all the numbers possible. You are using a calculator, so it's not that tough to do. At this point, find the maximum and minimum usual number of people who would recognize McDonald's. Round your final answer to the nearest tenth. So it would be the formula we used from before. The mu, which we just found, 11.4, plus 2 times my sigma, my standard deviation. That would be for my maximum. Again, use your calculator for this type of problem. So 11.4 plus 2 times my standard deviation would give me the maximum usual number, and my minimum usual number would just be me subtracting. So out of 12 people, it is unusual to find less than 9.9 people that don't know about McDonald's, right? And so in between would be a usual number. So usually if you ask 12 people, between 9.9 and 12.9 people will know. Would it be unusual or not unusual for a particular group of 12 people to have all 12 recognize the brand name of McDonald's? Well, it is not unusual, meaning it's usual. Just it's a double negative here. 12 is in the range of ordinary values. 12 is in between 9.9 and 12.9. Alright, so now go ahead, try these examples out. I'll be showing the answers, but I won't show exactly how they're done. The reason for that is because I want you guys to work hard on this one. So they're not that bad, they're not that hard. But if you have any questions, of course, you could always comment. You could always send it in the discussion page on Canvas. And don't forget that the homework, once this video is uploaded, the homework will be posted and should be open by then. So here are the 2 answers. These are the answers you should get. Again, if you get them wrong, just try again. It might be a calculation mistake. However, if you have questions on how, just comment, ask, and I will hopefully answer. Alright guys.